Hi everyone, my name is Andrew Adams, and I am doing this on behalf of Cal Poly Pomona Aerospace Engineering, specifically Dr. Coburn Structures courses. This is going to be a presentation on composite fabrication. I'm going to be going over both a professional type setting and what to expect and tips and tricks involved with that, and then also just a very relatable garage fiberglass project as well. So let's get started. Okay, so to get started, what we have in the photo there is your basic repair kit, commonly available at most auto parts stores or boat repair shops. It includes your glass, well, this one includes your basic glass fiber and epoxy resin, and also includes a hardener there along with squeegee. So very representative of a very easily accessible type of composite work. You can also see the tool that I prepared to lay up on there on the right side, that block of shiny aluminum. For a professional setting, you're going to be working in a clean room. You'd probably be wearing a smock, and your tooling would be much larger scale. You would have larger panels that you'd be flat panels that would be for your composite panels that you would lay up on. If it's a part that has a 3D shape or volume to it, then it would probably be from some sort of machined metal and stored off-site until it needed to be used. Not shown here, but also common tools would include things like razor blades, lots of gloves, acetone, IPA. Fun fact, acetone is going to be a little bit more hardcore on whatever surface you're working with compared to IPA. So if you're ever going to be doing any sort of cleaning work, you would initially start with the acetone followed by the IPA, isopropyl alcohol. Isopropyl alcohol is a lot more gentle on whatever you're working with, so just keep that in mind. Okay, now the tool prep. So by tool, I'm referencing, in this case, the piece of material on which the lamina are going to be laid up on. In industry, this tool can be rather large and kept off-site. If it's a specialized component, a lot of times they'll be kept in larger pelican cases or something that can protect the tool itself. That protection is key because the surface of the tool is probably the single largest indicator other than your own performance and your own actions as to how excellent the actual composite will turn out. For example, any imperfection on that tool's surface will then be imprinted onto the composite. There are certain allowables that talk about depths that are acceptable, and it's very easy to exceed those values. I have seen things as small as hairs be caught underneath a layup, and after cure, you can see the indentation of that hair onto the final component. So a clean surface is essential. If it is a three-dimensional part, a lot of times you will use a liquid Teflon and wipe it on with wipes in a number of layers and then bake it to a certain temperature. And then that would be your release surface. On flat surfaces, it's very common to use a material called FEP. FEP is a release film that will not allow any laminates on it to stick. Here for my homebrew project, I just used a little wax paper from the kitchen, and it will do just fine. One thing to address in that last slide, I mentioned the Kaplan tape. In industry, there's also this blue tape that you'll find ubiquitous, and that's probably most likely. Here in my garage style setting, Kapton tape is the best option. So again, industry standards in a professional setting are going to vary from what you have available in your garage. The layup procedure itself, again, as mentioned, it's probably a little bit easier than tool prep. You're just putting the pieces on. However, if it's garage style layup as shown here, it can be over in 2 minutes. You can have all of your plies down. So essentially you start with a thin layer of brushed on epoxy, then you stick your sheet, your mat, your ply down, excuse me, and then you can saturate that with more epoxy resin, and then so on and so forth. You could do layer after layer like that in rapid succession and be done. In a professional setting, each ply or every other ply, depending on the program or whatever is specified by your employer, you could have, it would be necessary to have a pressure debulk. And what that would mean is you're going to push the composite under vacuum and allowing that composite to compress further. And in most settings, in a professional setting, that's in pre-preg, you're going to be seeing that a lot. The thicker the laminate is spec'd, the more likely you will also come across high pressure debulk. So that's going to be after, maybe 10 plies, 10, 12 plies, depending on, again, your employer. It would go into the autoclave for 100 psi high pressure debulk. Now, just to give you context, 100 psi is enough to dent penny. So just to imagine how much force you're actually dealing with. That much pressure would be pushing those plies together, getting for a very nice finished part. One thing that really does need to be mentioned during the layup procedure is it is very easy to get lost on which ply you're laying down. It's embarrassing, but it does happen. And to avoid that, you definitely want to come prepared with a layup checklist. And I've given you an example of a layup checklist there to the left. That checklist might seem redundant, might seem a little bit of a waste of time, but it does provide security both for you and for whoever is going to be inspecting the part down the road that it was done correctly. Um, that little peace of mind has saved my rear end more than once, and it is something that I cannot recommend you do enough. So, with the cure and the part removal, we'll go ahead and assume that your part is now ready for final cure. It's ready to, if it's in a professional setting, ready to be bagged for the final time and put into the autoclave. If it is a three-dimensional part, you will need to make your final bag and you will have pleats to work with. There are many great videos on composites and proper pleating of that bag. Just understand that pleats are essential to do correctly if you don't want your bag to give under pressure during final cure. Nothing feels worse than to have a finished part that has a bag blown during the final cure. It will ruin the part, and up to 2 weeks of your labor will go out the door instantly. If it's garage material, as shown here, you can just leave it out in the sun for a couple hours in my case, and no bag, no pressure, and it was ready to go after a couple of hours. Part removal is important. As I mentioned at the beginning, tool prep is key. To give you a good example of what not to do, on the right picture there, you can see that when I laid down the plies, I laid them oversized in comparison to the wax paper that I initially had put down. What that meant is a lot of that epoxy and glass fiber material then adhered itself to the direct surface of that metal, none of which was treated with any sort of liquid Teflon coating. So therefore, it was impossible to remove. You can also see where I took a cutoff wheel to reflect where that wax paper that I had initially laid down actually was underneath. So once I had cut away, you can see how easily that wax paper, it just popped right off of there. There was no hesitation at all from the part. It was very simple to do. It did ruin the tool. So just be mindful of that when, if in a professional setting, a tool is going to need to be reused. Make sure that your full surface area and beyond is prepped to be able to remove whatever composite material is laid up on it. Yeah, very, very important. Okay, so lastly, your cleanup and trimming procedures. This is going to be After the part is cured, after you've taken it off of the tool, you're going to want to go ahead and consider that you've got very, very sharp edges, lots of little glass fibers that could be sticking out at different orientations. So the carbon does not feel great if you get it stuck under your fingernail. Ask me how I know. So in order to prevent that, covering those sharp edges is very, very important. Again, I broke out the Kapton tape for this. Again, in a professional setting, you might use the blue tape or something else. But the purpose of it is to protect yourself and those working with the material. Your part might not be cut down to size yet. Again, composites, the whole idea is you're going to oversize this initial layup so that you can cut that piece down to your final dimensions. So just be mindful that even though it's going to be trimmed later on, doesn't mean that you can't just have a little bit of safety right now and maybe save somebody a little bit of bloodshed. Um, Also, identify your parts. Always, always, always. A part can sit on the shelf for a very long time if you're not careful, and it's very easy to come to a part and not know what it's for 2 months down the road. So always identify yourself as the person or whoever made it. And then if there's a part number that it will turn into or anything associated with that, it's very good to also put that information down. Also put a date on it. Um, with that, this does cover most of your basics in terms of composite fabrication and some of the tips and tricks you can consider. Thank you. Hope you guys have a good one.